All right, so we're going to look at our inverse functions now. So just a review on that. So remember that your sine you do it like this. When we're looking for inverse sine of x, we are going to look in quadrants 1 and 2. And what we were saying before is that what we're looking for is actually bound between negative pi over 2 and pi over 2. So we're looking for answers that are going to be within this range. So if we're at quadrant 1 and 4, let me go fix that. So quadrant 1, everything's positive, but quadrant 4 is when we're going to get negative angles. So usually the mistake here was just trying to make sure things were negative when they were supposed to be. So we need to find inverse sine of 1/2. We need to use our unit circle, and we need to look in quadrants 1 and 4 to find sine equals 1/2. Sorry, pen fell up here. So if I'm looking for inverse sine of x is supposed to equal 1/2, then I'm looking for when sine, sorry, put the correct thing up here. Sorry, I quit sharing and I had to restart. So inverse sine of 1/2, remember this is just the equivalent saying this has to equal some sort of x. That means that there is a sine of some sort of x that equals 1/2. So we're just looking for sine is 1/2. We see that it's here, and we see that it is here. But remember that this is bound. I'm going to write this up here again. Bound between negative pi over 2 and positive pi over 2. So because of this binding, really the only thing I can look at is this quadrant or this quadrant. So I can only use this answer. So we see here what that is saying is that would have to be pi over 6. Now, if I had inverse sine of negative 1/2, well, my negative 1/2, I said that's going to be my x, sine x equals negative 1/2. So my negative 1/2 is going to be here, and it's going to be here. But once again, because I'm bound between quadrants 1 and 4, I can only really use this answer. So this is the one that we have a little bit of a problem with because remember, we're bound between negative pi over 2 and pi over 2. So this way is going a positive pi over 2, but going backwards, this is a negative pi over 2. So we need the negative direction. So it's not that we want 11 pi over 6, is that we would have to say 2 pi minus 11 pi over 6, which is going to leave me with a negative pi over 6. So it went in this direction, negative pi over 6 to rotate to that position. So this would be my answer, is the negative pi over 6. Now, sometimes things are going to be on quadrantals. So I could ask you something like, what is sine of, or inverse sine of 0? Well, that means that there is sine x equals 0 somewhere. So when is sine equal to 0? That would be right here and right here. But the one that's in my interval between negative pi over 2 and pi over 2 is this one right here. So we would end up having the 0 radians. So if we're talking about inverse cosine was bound between 0 and pi. So that puts it in quadrant 1 and quadrant 2. So if I was looking for say cosine of square root of 2 over 2, or inverse cosine of square root of 2 over 2. That means I'm looking for this cosine of some x is going to be equal to square root of 2 over 2. So we see that happen here, and we see that happen here. But only since I can only be in quadrants 1 or 2, this is the one I take. So this is actually happens at pi over 4. Now, if I ask you inverse cosine of negative square root of 2 over 2, so we'd have to find between quadrants 1 and 2, where do I have a negative square root of 2 over 2, which is right here. So there is another one down here, but like I said, I can only pick between these two quadrants. So we end up with 3 pi over 4. And this one, I don't have to do any conversions because I'm not bound between a negative square root of 2 over 2 and a positive square root of 2 over 2. I'm bound between 0 and pi, and this is in between 0 and pi. Now, what if I did inverse cosine of negative 1? So when is cosine negative 1? Well, cosine's negative 1 only here. And that just barely fits in because remember, we can be at pi. So this one is going to be pi. And that, once again, is my only solution. So if you remember the graph of tangent, one period is bound between negative pi over 2 and pi over 2. So inverse tangent's also between negative pi over 2 and pi over 2. One little change, though, we can't be equal because we have asymptote at negative pi over 2 and pi over 2. So this is a strict inequality. So if I was looking for inverse tangent of square root of 3 over 3, once again, remember we're in quadrants 1 and 4 because of that binding. Now, if I was looking for this one's a little more difficult to find than it was for sine or cosine. So remember that these are just cosine sine pairs. So what we could do is we could take them and just figure out what tangent would be. So here tangent would be tangent of pi over 3 would have been square root of 3 over 2 divided by 1/2, which is going to be equal to square root of 3 over 1, which is just square root of 3. Here, if we did a tangent of pi over 4, well, then the sine is square root of 2 over 2, cosine is square root of 2 over 2, so this one equals 1. If we do this point here at pi over 6, we do the cosine, the sine first, so 1/2 divided by cosine, which is square root of 3 over 2, so we're just using that reciprocal property. And I get 1 over square root of 3, which if we simplified it, turns into square root of 3 over 3, which is exactly what I wanted right here. So I'm going to move this part just to make it a little easier for us. So we're looking for inverse tangent of square root of 3 over 3. And we see that that happens if we are at pi over 6. Like only looking at quadrants 1 and 4. Now, if I was looking for inverse tangent of negative square root of 3, that's going to probably put me down here in quadrant 2 if I'm looking for the negative. Same thing again. Remember, if I'm going this way, this is a negative pi over 6. So at negative pi over 6, that's going to be negative 1/2 divided by square root of 3 over 2, which is going to be a negative 1 over square root of 3, or a negative square root of 3. Here, if I kept going, this is going to be not 11 pi over 6, but negative pi over 4. So tangent of negative pi over 4 is going to be a negative square root of 2 over 2 divided by square root of 2 over 2, which is going to be negative 1. And then if we kept rotating more this way, instead of having 5 pi over 4, this is going to be negative pi over 3. Like I said, because we're going this direction, we're bound between negative pi over 2 and pi over 2. we're rotating the negative direction for our inverse functions here. So tangent of negative pi over 3 is going to be negative square root of 3 over 2 divided by 1/2, which is going to leave me with negative square root of 3, which is what I was looking for. So my solution here, inverse tangent of negative square root of 3 is negative pi over 3. And then if I do for inverse tangent of 0, so it would have to be right here. Oops, because tangent of 0 is going to be 0 over 1. So we don't actually have to worry about answers that are going to be pi over 2 and negative pi over 2, because remember, those are asymptotes. All right, so the remaining ones we had were cotangent. So inverse cotangent is going to be bound between quadrant, or bound between 0 and pi, but that puts it in quadrants 1 and 2. Secant is going to be bound between 0. It can be equal to 0 up to pi over 2. But then we skip over pi over 2, and then we can go to pi. So this once again puts us in quadrants 1 and 2. And secant starts at negative pi over 2, goes up to 0. We have to skip over 0 because it's an asymptote, just like pi over 2 is an asymptote for secant. And then we continue to pi over 2. This puts us in quadrants 1 and 4. So if we were looking for cotangent of negative square root of 3, or sorry, inverse cotangent of negative square root of 3. So remember, this time, this is going to be cosine, then it will be sine. So if we went in this direction, so negative pi over 2, pi over 6. If we put sine on top first, square root of 3 over 2 divided by negative 1/2, we would have negative square root of 3. So this one's at negative pi over 6. Oops, sorry. I forgot, went in the wrong direction because it wasn't a tangent. I'm looking for cotangent. Sorry, that was silly of me. We're looking in quadrant 2. So if we go here, cotangent of 2 pi over 3 is going to be square root of 3 over 2 divided by negative 1 over 2 divided by square root of 3 over 2. So you end up with a negative 1 over square root of 3, which is not quite what I needed. Let me put it back here again because I erased it. So this one is going to be cotangent of 3 pi over 4 will end up being negative 1, and cotangent of 5 pi over 6, this one's going to end up being the negative square root of 3. So remember, you're putting the cosine on top this time. This is the one we don't have to worry about negative solutions. As long as you're in quadrants 1 and 2, nothing should be a negative as an outcome. Now, if I was looking for inverse secant of 2 square root of 3 over 3, so remember in this case that secant is just your inverse of cosine. So if it helps, think of it like this. If this is equal to an x, that means that there was a secant of x that is equal to 2 square root of 3 over 3, which means that there is a cosine x that is equal to the reciprocal, which is 3 over 2 square root of 3. So if you think about that and you put a square root of 3 on the top and the bottom, that is going to be 3 square root of 3 over 6, which simplifies into square root of 3 over 2. So where do we have a cosine of square root of 3 over 2? That's going to be right here. So that means that if I reverse that to the reciprocal, then I would have 2 over the square root of 3. That when I simplify it, it becomes 2 square root of 3 over 3. This one's just a little harder because we're working backwards. But that means that inverse secant of 2 square root of 3 over 3 is going to be equal to, what was it, pi over. And then if I give you cosecant, inverse cosecant of -2, if this equaled some sort of x, then that means that there was a sine x equals -2. One over -2, reciprocal. So we need to figure out when sine is equal to 1 over, or negative 1 over square root of 2. So remember, your cosecant is bound in quadrants 1 and 4, so we do have to look at quadrant 1 and 4. So I see my answers right here. So this is at negative pi over 6. So cosecant, or inverse cosecant of -2 is going to be negative pi over 6. Okay, so I'm going to skip all problems that required sticking things in a calculator. Just focus on the ones we need. So we have inverse sine of pi over 5. And we want to know what is going to be the output of this. Funky. So we had a rule that said that if we do an inverse sine of x is going to be equal x, just as long as x was going to be between pi over 2 and negative pi over 2. If it's not, then we'd actually have to go back and look for another answer. So what we have here is that we have pi over 5, which happens to be between negative pi over 2 and pi over 2. So that tells us that what's going to happen is that we are going to end up getting back pi over 5. And just to add it on here, because some of these switch between pi cosine too. So if you had inverse cosine of x, that's going to equal x, just as long as we have x values that are going to be between 0 and pi. Well, then it's because of that binding, right? Inverse sine is bound between negative square root of 2 over 2 and positive square root of, sorry, try it again. It's bound between negative pi over 2 and pi over 2. I was doing something else, reading something else in my head there. And inverse cotangent was bound between 0 and pi. So it's keeping that x in that binding. So then also if you had inverse tangent of x, we got x back just as long as x is once again there's no equals here. Pi over 2 and negative pi over 2 and pi over 2. So like we were saying, this one here was, we just have to make sure that our x is between 0 and pi. And we have 8 pi over 9, which is over 9, which is between 0 and pi. So once again, what we would get back is 8 pi over 9. So this is where we started running into a problem. So with that, rule for sine was inverse sine of sine x equals x, as long as x between negative pi over 2 and pi over 2. So 3 pi over 4 is not in that range. So it's not in that range. So as long as we start with an inverse, that was fine. Because if we go and we get out a unit circle, I'm not going to keep switching back to the unit circle. You should have copies of these. But if I do inverse sine of 3 pi over 4, then I'm going to get inverse sine, and 3 pi over 4 is going to give me square root of 2 over 2. And this is actually in quadrant 2. So remember, we're looking at inverse sine, which is in quadrants 1 and quadrants 4. So if I go try to figure out what inverse sine of square root of 2 over 2 is, if you go to your unit circle, I have to be in quadrant 1, which means I'm going to get pi over 4 back. So in this case, we just don't get, we get a value back, we just don't get x back. So if I'm stayed in this binding, then I would just get the same x back. Because I'm outside of that binding, what's going to happen is sine of 3 pi over 4 is actually square root of 2 over 2, but I can only look for inverse sine in quadrants 1 and 4. So if I look in quadrant 1 to find square root of 2 over 2, that means it's going to give me pi over 4. So it's just moving to a different quadrant. So this is a different situation. So now we got the sine is first and the inside, sine is first and your inverse is inside. So this has a solution. Make sure I got the right one here. Got a solution as long as that whatever that x is between -1 and 1. And the reason for that is that you're looking for we know that sine has a range between -1 and 1. So we're looking for an inverse sine. We're putting in numbers that are come from that range between -1 and 1. So we're just making sure that we actually have an answer here. So if you look, so you have 3 pi over my x, sorry. My x is going to be 4 pi over 3, which is 1.189. We'll just round it to there. So this is not between -1 and 1. And in this case, what happens is that means, if I was to look at this, this part right here, inverse sine of 4 pi over 3 is undefined. Which means if I'm doing the sine of something that's undefined, then what I'm going to get out is something that is undefined. So this would be our answer. So this one, when we were switching between, this is where we had to start constructing triangles. So we have a cosine that's on the outside. We got cosine of inverse sine of 8 over 10. So if I just focus on the inverse cosine, I got inverse cosine of 8 over 10, which is supposed to equal some sort of angle alpha, which means I know that sine of alpha is 8 over 10. So it's going to be 8 over 10, so sine is positive. That's it's going to put me, part here is going to put me in either quadrant 1 or 4. And because we got positives here, that means we're going to put us in quadrant 1. So this is where our triangle is going to be. We know sine of theta is going to be 8 over 10, so opposite over hypotenuse. So we just need to figure out what x is. We'd have x squared plus 8 squared is going to give us 10 squared. So x squared plus 4 equals 100. So that means x squared is 36, right? Yeah. It's going to be equal to 36, which means x is going to be either plus or minus. So because we're in the first quadrant, we know it's going to be plus 6. So now if we go back over here, we just said the inverse sine of 8 over 10 is equal to a theta. So this is just a cosine of theta. We already have theta set up. So for cosine of theta, it's just going to be 6 over 10. Which is going to be 3/5.